says we're on air.
Cool.
It happened.
Many things have happened. But is anyone actually watching? That's the question.
Well, let's say hi to some people anyway. I'm going to say hi to Rick Schwartz, Nancy Graziano, Guido Bibra, and that's it. That's all there is so far.
That's
just
sad.
those three.
It's the important people, though. It's the awesome, important.
It's the
people who follow us all the time.
It's the core group. For anyone who doesn't know why I just said hello to various people, you have to go to click the Q&A app. So wherever you're watching this video, it says that we're interacting with the community. Click that, and then you'll still see the video, but then there'll be a bunch of, oh, this is going to be a problem. Anyway, you're still going to see the video, but then there's going to be a bunch of comments over on the right-hand side, and you'll be able to click on that and type in your comment and say hello, and then I'll say hello back to you. Anyone else who's willing to do this?
We want you there. Where are you?
Yeah. All right. And for anyone who has no idea what it is they've stumbled into after your holiday festivities, and now you've got your brand new year to enjoy, you're going to watch an episode of Astronomy Cast. Today it's going to be episode 398, where we see things.
How we see things. Not where. How.
How. No, perhaps things that are there.
Oh, yes, that's true.
We're not seeing things that aren't there. That's all I'm saying. Seeing Things was a Canadian, I think, a Canadian kind of paranormal television show back in the 80s. So,
okay.
You've never heard the term? Have you ever heard the show Seeing Things? I think it's Canadian. So there you go.
See, the Canadian thing to do. I got that.
Yeah. Anybody else? Helge Berkhog is there. Yeah. Yes. Hello. Okay. Man, have we talked about Star Wars? I don't think we've even talked about Star Wars yet.
No, because there are people who haven't seen it yet. I have seen it. I've behaved this time, but my husband hasn't seen it. So no talking about it yet. I think one more week, and then if you haven't seen it by then, you have no excuses because the theaters have finally started to empty.
As Chaz says, 1:30 a.m. here. This better be worth it.
We try.
I don't know if staying up till 1:30 to watch a live episode of Astronomy Cast is going to be worth it. If you're like killing time at your job, then I think that's worth it. You know, you just like got another window going and you're hanging out with us while you're running those TPS reports. Sure. but if you're, Richard Russell says, hello, happy arbitrary delineation between orbits to you. Hello. It is truly arbitrary.
It is. It is.
So many things in our, the length of day, the length of year, they are done by nature, but the actual day that the new year begins on is completely arbitrary.
Yes. And did you hear the bing that just went off?
No, did something bing?
Okay, then I'm not going to try and find it.
Okay, good. Right. So Star Wars. Yeah, we watched it. It's going to be on track to be the biggest grossing movie ever made.
So on one of the sites, not Mashable, but Gizmodo or IO9, one of those, I saw a post that mentioned that the book version of the movie puts in details that are canon that you may not have picked up on watching the movie. This is an Alan Dean Foster book.
Yeah.
And I'm currently, actually, I think I finished the book yesterday. Yes, I finished the book yesterday. No brain.
Foster through all the Star Wars books?
I think so. Yeah. I think so. And the book kicks ass.
Oh, good.
So I strongly encourage, there were a lot of nuances. I'm going to go back and see the movie a second time. And yeah, spend more money on Star Wars, I guess, is the moral of the story.
Yeah. Okay. So why don't we do this thing? Oh, I've got one little piece of news, which is that I'm going to be on Cord Killers today at 5 Pacific time.
And what is this Cord Killers?
Cord Killers is with Brian Brushwood and Tom Merritt, and where they talk about the state of television cord cutting. And it's like one of my favorite shows, and I've been on it multiple times, and I love to talk about being a cord cutter. So I'll be on that show with them at 5 o'clock. So if you haven't already heard of cord killers, then you should totally come and join us because it is a good time.
Sounds
And then the
excellent.
first half is talk about all the big news in the cord killingness. And then for the second half, we spoil things that we've all watched. So if you listen to it, then we would spoil Star Wars. Okay, cool.
But you warn people before you do this. So that
spoilering time, and so you show up there and you know that the spoiling will happen. So if you listen to it and you got spoiled on something, it's really your fault.
Okay.
That you weren't there for it. Yeah. Okay, cool. Let's I say we begin this little thing we like to call Astronomy Cast.
I think we can do that. I'm going to press record and watch it actually record, and it's working.
I am also recording. Okay. Here we go. Astronomy Cast, episode 398, Seeing Things. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela, a professor at Southern Illinois University, Edwardsville, and the director of Kozma Questions. Hey, Pamela, how you doing? Happy New Year.
Happy New Year's to you. It's 2016, and this means that we've been doing this show
forever.
For 10 years, basically. So we started September of 2006. It's now 16. Kind of cool.
There you go. We were podcasting before it was cool. We were podcasting before it was even acceptable. We were podcasting while it was still embarrassing.
Yes, that's true.
Yeah.
That is entirely true.
Cool. So I think, but we got lots of good shows planned for 2016.
Yes.
All the way through till our summer break. So hang on. It's going to be a fun ride.
Yes.
Astronomers gather electromagnetic radiation with their telescopes, mostly visible light, but sometimes they got to be clever about where they look for these elusive photons. Light can get emitted, absorbed, reflected, and each method tells astronomers a little more about what they're looking at. Okay, Pamela, so you put this on the docket. We're going to be talking about different ways that we see the light and the different journeys that this light takes to make it to our telescopes and eyeballs.
Yes.
So where do you want to start?
Well, first of all, I wanted to describe why I came up with this crazy topic, because this was one of those things that has never appeared on any list we've ever had or been requested by any listener. But the other day I had a drive-by moment on Twitter, one of these, zoom in to look something up on my computer and see this amazing photo on Twitter. And it was the Twitter equivalent of a driveway moment where you have to pause to figure out what you're looking at, like you do sometimes with an NPR story where you sit in the driveway to figure out what the story is about.
Yep.
And it was this photo that showed ionized light emitted through the ionization process by a meteorite going through the atmosphere. It showed reflected light from a comet, and then it had all the stars and galaxies in the background. And it was one of these amazing moments of ionization, reflection, and emission all
in the same picture.
And it was this moment of seeing these are the three ways that we're able to see our universe. Okay.
So I guess that's the part that people maybe didn't realize before they were listening to this specific show, is that there are these different ways that photons get emitted.
Exactly.
And that we can then absorb them, and each one tells a different story. So let's start with the sort of the most common one, the source.
Yes.
Which is the emission.
Exactly. So when we look at anything that is hot, it's going to be emitting what's called black body radiation. If it's a stone, a rock, a star, a piece of asphalt, if it's any of those things that Captain Kirk could light up with his phaser. All of this warm stuff, your hamburger does this if you eat a hamburger for lunch. All of this warm stuff is emitting light in a continuum of colors, an entire rainbow. And there's going to be a specific color where it gives off the most of its light that corresponds exactly to the temperature of the object. As objects get warmer and warmer and warmer, they go from giving off the majority of their light in the infrared, which is what we humans do. We're little black body thermal radiators, to giving off their light in colors that are more like green, which our sun does, although our eye perceives the sun as white just due to our inability to perceive green really well. Different objects,
but also just that it averages out, right? I mean,
it averages out, yeah.
Right, that we are emitting, or that the sun is emitting photons, that we're emitting photons, that the cosmic background radiation is emitting photons. There's photons coming from all these things.
Any warm source, any hot source, and by warm, I mean anything greater than, absolute zero, everything is emitting photons in this spectrum of colors to a point. Now, the to a point is exceptions like if I look at a compressed sodium light bulb, I'm going to see stark emission lines from the sodium because that's a pure substance that doesn't have the ability to give off light in every single color. It doesn't have thermal emission. It has emission lines due to the chemistry involved.
And so when we think about a thing that's a color, right? Like when we think about, you mentioned the sun, but when we think about a light that is green, or a light that is blue, and we're seeing blue photons coming off of that object, we're actually seeing, as you said, the black body radiation. We're seeing a spectrum of photons coming from that object, and it's just where the majority is that's the color.
It's how they add up and are perceived by our human eyeballs. So there are stars out there that give off the majority of their light in the ultraviolet because they're extremely hot, bright stars. But our eyes don't see those colors. But what we see is all the colors that are, visible in the colors our eyes can see. So we perceive these stars as bright, bright blue. At the same time, there are stars that have peak radiation out in the infrared, which again, our eyes can't see. So we'll perceive them as a deep, deep red because they're still giving off a lot of light in that tail of the black body spectrum that's in the visible red. So that's hot things that are giving off thermal emission, where it's everything bouncing around and emitting every possible color of photon. Then, like I said, there's also that emission lines that come from specific atoms going, and now I shall let my electrons jump from this level to this level. And when that happens, a photon is emitted for emission lines. Or there's also cases where they're absorbed out, which we don't see with our eyeballs, which is an absorption spectrum.
So can you talk about that emission, those specific emissions? So, if we take a rock and we heat it up,
that's thermal emission.
Thermal emission, right.
Yes.
But in this case, it's giving off photons that are in the infrared. They are getting emitted, and they are sort of across the range. Like they're literally just different wavelengths. Some are a shorter wavelength, some are a longer wavelength. And we perceive the warmth from the rock with the eyeballs that are our hands, that we feel the temperature coming off of the rock, and it's an average temperature. And that is sort of, again, this is kind of like the average of all of those photons that are getting emitted. But you said that you can have situations where photons will get emitted in a very specific emission line. So what's going on there?
So here we have a different kind of situation. With the thermal emission, it's everything bouncing around and that kinetic energy, lots of complex physics, you end up with a continuum of photons coming off. If you have a single element or a cloud of specific elements, for instance, inside of a fluorescent light tube, inside of that compact sodium bulb, if you then look at that specific chemical mixture, using a pair of those rainbow glasses you can get in novelty stores, you'll see the light get spread out into specific lines of color. And different lines will be different brightnesses. So if you go and look at a bright red open sign, a neon sign that's actually probably filled with hydrogen, you'll see a really bright red line and some other fainter lines. And what's happening is you have the electrons. Well, that red line comes from an electron falling from being excited up to the third energy level in hydrogen and dropping down to the second energy level in hydrogen. And when the electron changes energy levels, it gives off a discrete photon that has a very specific energy that is a shade of red. When an electron goes between two other levels, 2 to 1, that's going to be a different color. And in that case, it's a color we can't see with our eyes.
And this is very useful for astronomers.
Yes. Yes. So for instance, if I'm looking at hydrogen at any place in the universe, I know that those hydrogen spectral lines, that 3 to 2 energy jump that gives off a photon, that 2 to 1 energy jump that gives off a photon, wherever I look in the universe, the photons are emitted at the same color. But if that object's moving relative to me, perhaps getting carried away by the expansion of our universe, that color is going to get shifted toward the red if it's moving away, toward the blue if it's coming towards us via its own volition. That's not going to happen with most galaxies. And I can measure that velocity, that Doppler shift, by looking to see how these known colors get shifted redward and blueward.
And so in this case, right, astronomers have a very specific filter that they can put onto their telescope to only filter that very specific wavelength into their CCD, into their cameras, right?
So we do that when we're looking at things within our own galaxy, where we know that the relative velocities aren't that great. We'll throw what's called an H alpha, a hydrogen alpha filter for that 3 to 2 energy jump. And this allows us to focus in on the hydrogen in local nebulas, the hydrogen in local star-forming regions, and see them detailed. We also might do this if we're looking at the sun, in which case we also use a lot of neutral density filters to bring down the amount of light we're looking at. But when we're looking beyond our own galaxy, where things can get shifted to radically different wavelengths, there are times that we use custom-built filters to look for things at very specific wavelengths. But most often what we'll do is look at an object through a spectrograph, through a device that's designed to spread the light out into a rainbow by either putting it through a slit or reflecting it off of what's called a grism. Through all of these different techniques, sometimes using prisms and slits in combination. Using all of these different techniques to create this rainbow, we can zoom in and say, I don't know how fast this object is moving. I don't know what atoms are in it, but I'm going to look, and then I'm going to identify these fingerprints of atomic spectral lines based on their spacing and say, now by looking at how this fingerprint is shifted redward or blueward, I can get at the velocity of this unknown object.
Okay, so that was the first part of your, I guess, of that comet, meteor, star image that you were talking about, and that's the emissions, and that's sort of this great fingerprint for seeing what, you know, speeds that galaxies are moving away from us or towards us, even some of the chemical constituents of some of those galaxies, which ones are having more star-forming regions, things like that. So let's go for the second one then. Let's talk about the ionization that you saw in that image.
So this is where an object decides to make its reality known by heating up the stuff around it till the stuff around it gives off light. So for instance, if we have just a grain of sand colliding with the Earth's atmosphere and plunging down through that atmosphere, which is what happens during meteor storms, which some of you may have seen with the Geminids in December, when these particles plunge down through our atmosphere, they have a lot of kinetic energy that they lose to the atmosphere as they frictionally interact. They lose their velocity. The energy ends up getting transmitted to all of the particles around them. And one way of looking at energy is temperature. And when that transferred energy hits the equivalent of about 10,000 degrees, that will cause the hydrogen to ionize. Different chemicals ionize at different temperatures. At the end of the day, when we see that blue-green streak through the sky, what we're seeing is the oxygen, the nitrogen, all of the different atoms that make up, and molecules that make up our atmosphere, are getting hit with so much ionizing energy that they give off light.
So the meteor, as it's passing through the atmosphere, is heating up the atmosphere. This heat is then going into these atoms in the atmosphere, and they're, when they hit a certain point, they're then giving off more photons.
They're just flat out giving out photons. A normal everyday nitrogen atom is just hanging out going, hi, I'm nitrogen. That molecular oxygen in our atmosphere, it's just sitting there being quiet, blocking light.
Yeah, very stable, happy to hold on to its photons.
Happy to hold on to its electrons. And as that meteor streaks by going, hi, here, have my kinetic energy.
Enjoy.
Exactly. Those electrons are no longer so happy to stay in their energy levels, and they cascade to higher energy levels and then drop back down. And it's in that drop back down that they give off all of this light that we see.
And so again, what does this tell astronomers?
Well, it first of all tells us, hey, there's something high energy right there. There's a meteor passing through the atmosphere. And based on what colors we see, we can start to see what is at different levels in our atmosphere that's getting excited. One of my favorite examples of this interaction with our atmosphere is the aurora borealis, which occurs when high energy particles cascade along magnetic field lines in the Earth's atmosphere, give up their energy to the surrounding particles, and we end up with these amazing light shows. And depending on what color we're seeing, that's different altitudes in our atmosphere that are getting excited. That's different molecules that are getting excited. So we can see, based on the colors of the aurora, how deep into the atmosphere the particles are plunging.
So just to sort of discuss that situation, right? So you've got these high energy particles coming from the sun. They're moving with a tremendous amount of velocity. The Earth's magnetic field sort of pulls them, directs them as they sort of interact through, directs them down into the atmosphere. And same thing as the meteors, they are giving off energy into the surrounding atoms, and those atoms are then having the electrons, rise and drop in energy levels, and that is generating photons that we then see as this ionized radiation in the sky.
Exactly.
The colors, right? We get these blues and these greens. Is there a correlation between what's causing those colors to be the colors that we see?
Different colors are actually coming from different atoms and molecules in our atmosphere. So when you see different colors, you're seeing different parts of our atmosphere, quite likely at different altitudes, getting excited. And we did an entire show on this a while back. So go ahead and look up that show, and it talks about specifically what color corresponds to what atom.
Okay, so we've got emission, we've got ionization, and the last one I think is reflection.
Exactly. And reflection is how we understood pretty much everything we knew about our own solar system other than the sun up until about 50 years ago. Everything we knew about other worlds came from either sunlight reflecting off of them or from our own attempts to bounce radar beams off of things, which is another way of reflecting light. So when we look at Jupiter in optical colors or infrared colors, the light that we're seeing is largely reflected sunlight. When we look at Mars, it's largely reflected sunlight. Now, the reason I say largely is these are large warm bodies, and Jupiter in particular gives off excess energy because it is generating thermal energy just by being a large collapsed ball of gas that's getting crunched by gravity. Mars has still not fully cooled off and is a warm object. But the majority of the light we see, especially in the optical and the infrared, isn't that hi, I'm warm light. It's instead reflected sunlight. And it's kind of weird to think about. If our sun shut off, suddenly we'd be blind to all of these objects. And this actually led to people to start thinking about, well, is it possible that dark matter is nothing more than planets that are so small and so far from their stars that they are, as they run loose through the universe, creating the appearance of there being dark matter? Don Winget, one of my faculty at the University of Texas many, many moons ago, made the comment that you could explain dark matter fairly well by roughly 1 Acme brick size chunk per solar system sized volume of space in the universe. Now that assumes even distribution. You have to adjust the distribution of Acme bricks to get our actual distribution of dark matter. Programs like the Macho Project looked really hard for these small blobs of undetected planet masses and didn't find them. So between the Macho Project and our own detection of things via gravitational microlensing over the years, it's becoming more and more clear that Acme bricks don't explain dark matter. But there still are certainly planets out there that are via various matters ripped from their stars that we will never see because they're cold and they're failing to reflect light in a meaningful way.
And so, the objects in the solar system are just one example of the kinds of things that you can see with reflection. You can also see nebulae, right?
You can see nebula through reflected light. Anytime you're seeing a blue nebula, that's actually what's called a reflection nebula, because the light is moving perpendicular to your line of sight through the cloud and then getting reflected off of particles and scattered back towards us here on Earth. When you see a red nebula, that is where the light, just like with a sunset, the blue has been scattered away and the red makes it through straight to your eyes. So with the red, that's transmission. But when you see the blue, that's reflected light.
One of my sort of favorite ideas in this sort of world is light echoes. And I think we did a whole show on light echoes, but just this idea that you can actually see this expanding sphere of reflection around objects, stars and things inside a nebula. It just blows my brain,
And one of my favorite discoveries from the Macho Project had nothing to do with what they were planning to do with the Macho Project. But as they observed the areas around the large, I believe it was the Large Magellanic Cloud, year after year after year, they were able to see these, what they thought initially were optical defects, these bands of light through their images, appear to move over time. And as the bands moved, it became clear these were not internal reflections. These were not defects in the images. These were echoes of long past supernova. So what happened at the dawn of civilization is still echoing through our universe. And what happened at the dawn of our planet is also still echoing, but a lot harder to detect because those echoes are much more spread out.
Yeah, and so if you miss the supernova on the first time as it goes off and you miss the light directly, the light is going to escape through the surrounding nebula or the surrounding material that maybe the star had sloughed off years before, and that you can get other shots, other chances at seeing this light bounce back as it passes through this layers of material. It's a fascinating concept. So, I mean, that's another example. Are there any other examples maybe that astronomers will use reflection to study something?
Well, one of my favorite examples of this, it builds on the concept of light echoes, and it's V838 Mon. This is a very strange star that had a couple of flares back in, I believe the detection was in late 2002. It may have been early 2003. And these flares reflected off of all of the gas and dust that surrounds this star, which is in a fairly dense pocket. And as the light continued to radiate and bounce off of more and more complex parts of the dust and gas around the star, we saw this evolving picture of clouds being illuminated one after another. And we learned about the structure around the star. we were able to detail how the color evolution of the flares took place by looking to see, okay, so this part is this color, this part is this color. It gave us so much information about both the star's flare event and the intervening matter. And then it was just plain weird. And anytime you can have something weird and unexpected and beautiful with the thing that you're looking at forcing you to define new ways to understand our universe, that's kind of awesome. And this was one of those awesome things. And it happened to be a variable star, so I'm a fan.
And there's lots of other examples, really kind of cool tricks that astronomers have done with light, like ways to study the reflectivity of Earth by looking at how the light from the sun is reflecting off the Earth and then onto the moon.
Yes.
And you can measure the Earth shine on the moon. And then you can use that method in theory to search for extrasolar moons, to study extrasolar planets. Like all of these tricks that we're practicing here in our solar system will then have versions of that are going to be useful for studying whole other solar systems.
And at the end of the day, the only way we can see the faint, tiny Kuiper belt objects that haven't been visited by a certain little tiny mission called New Horizons is to look at them in reflected light. And we can guess at their compositions based on how much light they do and don't reflect. Their albedo is the fancy word for this. And highly reflective objects, we guess at being icier, less reflective objects, we guess at being, well, a little less icy, a little more sooty, or covered in carbon stuff. We have to guess at this information based on how well things reflect light.
Very cool. Anything else on? Should we wrap this episode up? We've talked about the 3 ways that we see the light.
I think we're good, and I'd encourage everyone to go out and force yourself out of bed when the weather says it's going to be clear, and take a look at the Catalina comet that's up right now, and maybe you too can catch that moment of a shooting star, a comet reflecting light, and all of the beautiful stars in the background.
Yeah, it's very close to Arcturus right now, I think.
So easy to find and lots of information. Just give it a Google.
All right. Thanks, Pamela.
My pleasure. And save.
Save. Save that into the Dropbox. Oh, that was $3.98.
Mm-hmm.
Export it.
I wish that Audacity could remember where I want to put things.
Yes, it doesn't remember that.
No.
I'll give you that.
It makes me sad.
Oh. Okay. Okay. Save that. I'm safe.
I'm getting towards safe. Something went bing very loudly into my headphones. Okay, I'm back.
Okay. Let us answer some questions. So let's see. Nickel Gatniskar, watching Astronomy Cast at 1:30 a.m. is worth ruining the sleep. Aw.
Yay. Thank you.
Yay. I'm not sure if that's true, but
how many times have you done the Just More episode on Netflix?
Just one more.
Yeah,
that's true.
We're the Just One More.
Guido Bieber says, and happy 4th anniversary Kozma Quest. It all began on January 1st, 2012. And we all have another anniversary coming up tomorrow and in September. It began. Do you remember where the thinking for Kozma Quest began?
It was in the Marriott bar.
At
not Marriott, at the Hyatt bar. It was whichever one is the furthest one from the Hilton. It was in the Hyatt bar. We stole a piece of paper from the waitress and realized this bar actually has glassware if you stay until Tuesday. So it was the Tuesday after Dragon Con.
That's exactly right. Yeah. And we were like, how can we get more people, all of the fans that we have of Astronomy Cast, how can we get them more involved in actually doing science? Both teaching them more about science and also just getting them directly involved and bridging that gap, because we really feel that the people who are excited and fans about astronomy and science in general would love ways that they could participate. And that led to all of the work that you've been doing over the last 4 years, which is just amazing. So, and
what's been really awesome is we created this community in hopes that they'd help us do science. And then due to sequestration, the government shutdown, and a lot of nasty US politics, we had a huge lack of funding for several years. And that community that we asked just to help us do science, they came in, and I have to admit, in that 11th hour, it was down to me and Corey. And Corey was full-time trying to man all the software, and I had cut my salary. We're not going to talk about that. But he and I were holding down the fort with a lot of volunteers, and we were being paid out of donations. And because we carried everything through, we were in a position to put in a proposal to NASA, survive until we got word that the proposal had been accepted. And today is the first day, in theory, we've been told we have a start date. We don't have our award letter yet, of a 5-year cooperative agreement that will not just keep Corey and I going, but George is back, and we're looking to hire a bunch of people, and we're growing so many things. There will probably be a future episode on that. I'm going to lobby Fraser for that.
That sounds great. We'll do that. Why don't we, whenever you know what's going on, why don't we do let's do an episode just on an update on Kozma Questions. We talk about the sort of the formation of it and just what our sort of hopes and dreams are. Because I find, you know, you and I, we're both super busy, and sometimes if you just explain the philosophy about what you're trying to do, people will pop out of the woodwork and help you kind of move the ball forward, because, you know, it's just like so many little pieces to think about that it never even occurs to us. And it will show up it's amazing when people just show up and do something really great, and you just didn't even, I'm sure I'm uploading my files to Dropbox right now. It's amazing how people will show up and just participate and help out, and it just means so much to us. So I'd love to do a show just about sort of where we're at with Kozma Questions, so people can kind of sort of hear what our goal was and where things are at. That would be awesome.
Yeah. And we're also looking for a bunch of volunteers to help us on the social media side and stuff like that. So, yeah.
Yeah. Okay.
Drop me an email. We're growing.
Okay.
Okay. Other questions that require less paperwork from me.
So Ed Thompson says, Happy New Year. Have you had a chance to look at Comet Catalina yet?
No, I live someplace that one of the reasons we didn't record last week was because I kept having power outages and had sufficient water in the basement that it put out our pilot light. So yeah, we're now dry and recording, but haven't seen it yet.
No, I haven't seen it either. I should though. It's just been bitterly cold and clear here. So it's been clear.
You define bitterly cold, Canadian.
Oh, -5 Celsius.
That is not bitterly cold.
It is to me. I'm a West Coast Canadian. We're the Florida of Canada here on Vancouver Island.
I understand.
Yeah, but it's so cold. It's like below freezing. Yeah.
I still bike ride at those temperatures.
We have to defrost the hummingbird feeder every night. That's how cold it is.
Is that actually a thing? Do you actually do that?
Yeah. Yeah. Well, see, so here where I live, hummingbirds last all year long. And so if you get hummingbirds dependent on your feeder, you have to keep the feeder going, or the hummingbirds will run out of that source of food.
No, that's a really real. Okay, I had no idea that you had hummingbirds that far north.
Yeah, so we have hummingbirds. So we have hummingbirds all summer long, and then we have a few the anise hummingbirds, they stay over the winter time as long as they have adequate sources of food. So they eat bugs, but they also go to your hummingbird feeder. So we keep a hummingbird feeder going all year long, and it's a bit of a challenge in the wintertime because it freezes every night. So we put it out in the morning before they start feeding. These are the things that I've learned from Carla, from my wife. So yeah, it's pretty funny. She's I would never have kept a hummingbird feeder going, but now I'm often the guy getting up at 6 a.m. to put back out for the hummers.
So this is a science fair project for you to work on. With horses, we just use a resistance coil, just like you get for travel coffee cups in their water buckets, and it keeps the water warm. You should be able to very easily build something that will automatically keep the hummingbird feeder from freezing.
A little battery, a little resistance coil, and a little solar panel on it, and that way it just recharges over the day, and then that's clever. Okay. Or just put it out at night and pull it in at night and put it out in the morning again. David,
I like to over-engineer.
No, it's good. It's good. And Carla's just the person to do this. Saw Star Wars twice so far and planning several more times in the theater. Completely amazing. This is David Joseph Wesley.
I'm right there with you, David. It's amazing, and
I'm the worst person.
Have you not seen it yet?
I've seen it, and I thought it was mediocre. I thought it was meh. And I feel like I'm the only person. Actually, I found a few more friends who agree with me. But yeah, no, I was underwhelmed. And yeah, isn't that terrible? I'm an awful person. I feel so bad. I should have loved it more, but I just had all kinds of problems with it. Which I can't talk about because I don't want to spoil it. So, but if you're one of those people who saw it and said, "Wait a minute, but what about? Come on," then you know where I'm coming from. But
okay,
anyway.
Maybe the catch is to see it early in the morning in a matinee when you're not fully awake, and you just sort of are like, "Oh my god, all of the sensories!"
Oh yeah, no, for sure. It fills up your eyeballs and
and I saw it in 3D IMAX, and my neck actually hurt the next day.
I wish I saw it in 3D, but I didn't see it in IMAX. That would be amazing.
Yeah, it was.
No, I mean, I would still see it again, and I'll watch the next movies. But I was, I was.
It's okay. It's okay.
Yeah,
I allow that.
Okay, let's see what else we got here. Richard Drum, the astronomy bum, says spectroscopy is the key to the universe. Tell us about the Balmer and Lyman series of lines. So we did a whole episode on spectroscopy, and so we kind of tried not to go too deep down that rabbit hole.
So that 3-to-2 connection that I was talking about, that's the Balmer first Balmer alpha line, and the 2-to-1 is Lyman alpha. So basically, if you're going from the first energy level somewhere, that's a Lyman line. If you're going from the second energy level somewhere, if you're going from the third energy level somewhere, that's a Lyman series line.
So Chaz says, I have a light emitting source horizontally traveling near C. What happens to the light coming to the left and the right? What happens to the light perpendicular to the horizontal path? So does that question make sense?
You have a ball. Your ball is emitting light.
Spaceship, a very bright disco ball spaceship moving.
I'm good with that.
Sideways.
Yes.
To your vision, and it's emitting light.
Nothing happens if it's going sideways to your vision.
Nothing happens.
It's good.
It's good. Yep. So if it's moving sideways, then from your perspective, there's no red or blue shift happening.
But only when it's straight in front of you. When it's over here, that counts. There's two components to the line. So when it's straight in front of you, strictly horizontal, there's no change. When it's coming towards that strictly horizontal position, it's blue shifted because it's coming towards you. When it's moving away from that, it's red shifted. So the way to think of it is when the line from you to it is shortest, no change. When the line is going from greater distance to lesser distance, blue shifted. When that line is going from lesser distance to greater distance, red shifted.
Yep. So David Joseph Wesley says it's Newton's birthday. Coincidence for today's episodes?
I thought Newton's birthday was December 25th, or does that depend on which calendar you use?
It depends on which calendar you use. And I'm sure if we all go back and watch the appropriate episode of The Big Bang Theory, where they celebrate Newtonmas. But so it's in the Gregorian calendar? No.
I don't know these things.
December 25th in the Gregorian calendar anyway. So yeah.
I look it up every time.
Richard Drum says the waxing moon will occult Aldebaran on January 19th, 9:24 p.m. for the East Coasters. And the dark edge will make the star turn off in an instant. Way cool. So the dark edge of the moon is going to turn off Aldebaran.
That is super cool.
Yeah, not Aldebaran, which was destroyed.
Yes,
Aldebaran, which is
as someone with dyslexia, I have made so many mistakes.
Yeah, have you written that out wrong so many times? Yeah,
or I've read it wrong so many times and just had moments of wait, huh?
So Nancy Graziano notes that the U.S. Postal Service is releasing a series of stamps this year to commemorate the solar system, including a panel dedicated to New Horizons and Pluto. So if you know the story, there was the original stamps, and it had all of the planets, and then it had Pluto, and it said not explored yet, I think. And it was just the artist's illustration of Pluto. And that was back in 1991. And then in 2004, they launched New Horizons to Pluto, and Alan Stern and team nagged the U.S. Postal Service to take another crack at this and do some more Pluto stamps, but this time, with the updated imagery, and it all came together. And so you can actually buy the stamps. There's also some great ones of the moon, and they're moon shaped to celebrate International Moon Year, and they're international stamps. So yeah. With the US ones, the Pluto ones only go in the US forever, and then the moon ones are international stamps, so it lets you send one letter to anywhere on Earth forever, which is really cool.
Yeah,
I just did a story about this. Can you tell that I know a little bit about this? Okay. But someone was like, I never send letters anymore, so what could I use for these Pluto stamps for? And I suggested that you could send Pluto stamps to other people.
Yeah.
Using your Pluto stamps.
There are some people out there like at Sandy, if you follow her on Twitter, who send New Year's cards and birthday cards and I'm on vacation cards, and
yep.
And Morgan, who does weekly space hangout, is another person who
I got a card from Sandy too.
They're awesome humans who know how to do this physical reality thing. And
so I've been having to think. So let me, so here's my idea, which is that so my wife does she has an English Bull Terrier, and apparently all the people who have this dog are super nerds about this dog. And so they do a Christmas circle where they send each other Christmas cards every year to pictures of their dog.
Okay.
And so I was thinking that we could, as part of Kozma Questions or part of Astrosphere, something like that we could organize some kind of, not Christmas necessarily, but some kind of, where we all put our names on, and then we all randomly get 10 people that we send cards to, and then we all send cards to each other.
That would be cool. That would be cool? Actually be really cool.
Yeah. And so, maybe like your favorite astro photo of the year or whatever. We come up with we pick up some time, and then we all put our name on the list, and then we all, we register, and then you get a selection of who your secret Santa, who you're going to be sending cards to are. And that would just kind of keep the community, add one more kind of cool thing that we all do as part of the community. I think it would be fun.
I agree. That would be really
brings her such happiness when she gets these cards. So that's it. That's my think. That and my symphony during the 2017 eclipse. These are all the ideas.
David Joseph Wesley is hopefully working on, assuming he doesn't get eaten by a grue.
Is that
Random.
possible?
You can always be eaten by a grue.
Okay. All right.
Mine is called Inbox. So I'm not seeing any comments on Twitter, but I am noticing that one of our favorite humans, AST Vintage Space, Amy Shira Titel, is gearing up to live tweet Apollo 14 this month. So
Yep.
those are always a blast. Do you have
Super
anything
fun.
awesome coming over on Universe Today we should know about?
Well, the thing that just happened was Dave Dickinson just released his guide to all of 101 things to see in 2016. So we've got a list of all of the meteor showers, occultations, eclipses, everything for the whole year. So all the stuff you can predict, David has predicted them all. And then of course that turns into 101 articles that Dave then publishes on Universe Today. But if you want the kind of the sneak preview of all of the big events that are going to be happening in 2016, so you can just sort of schedule, cool events with your friends, go check that out. And that's on Universe Today. It's called the 101 astronomical events for 2016, and
That's
which,
awesome.
by the way, we've just redesigned Universe Today. So if you haven't seen that, we totally rebuilt it, and we're still this deep in fixes. But
yeah, we're getting ready to do that to Kozma Quest, and if things go Picasso, please forgive us.
We should probably wrap things up.
There was one more thing I wanted to say, and I'm not. Oh, 365 is continuing for 366 days in 2016, which is a leap year.
It's a leap year. Oh, cool.
It's a leap year. So 365 for 366. Check it out. And we do need donations to keep this community-based podcast going. And we need content. Astronomy Cast, Ask Alice, Astro Info. Can't speak English. There's a whole lot of shows that I'm going to mispronounce if I try and say anything, who are all part of it. Check it out. Richard Bum, the Astronomy Bum, is our producer, and everything is organized by the ever awesome Movie Imani. I work with fabulous people. Fraser's not the only one. He's just the loudest of them.
The loudest.
It's said with love.
So here you go. So Carla just passed me a bunch of her cards. So these are the dogs, right?
That's adorable.
Yeah, isn't that? See, so Choopy, we're home. I guess that's the name's dog, is Choopy. And then do they make these things?
That's fabulous.
Isn't this crazy? Yeah. And then here's Carla's, which I don't know if you can see the
Yes.
So we pulled beach glass off of the beach, and then she turned them into little
eyeballs,
white bull terriers in Canada. So yeah. So anyway, that's a thought. If anyone wants to pick up that ball and run with it, we should talk about it and think of something. I think it'd be a lot of fun.
I agree.
And hang out. So
yeah,
that's one of my New Year's resolutions, is to try and hang out with people in this community more this year.
I'm going to start office hours online where it's like, hey, this time every week, I'm going to open a hangout. Anyone who wants to join me can, up to 10 people.
Yep.
So yeah, maybe that's a thing we should start.
Yeah, that sounds good. Okay. All right. Well, thanks everyone for watching. Thanks, Pamela, as always, for bringing the brain. And we will see all of you Friday when we do the Weekly Space Hangout returns.
That sounds awesome.
And of course, once again, a reminder, today, 5 o'clock, Cord Killers. Google it, and you'll be able to find out where to watch it live. So, cool. All right. Thanks, everyone.